Hi, I'm Jeff Carpenter, Technical Evangelist at DataStax, and I'd like to talk with you about data modeling in the real world. Whether you're a veteran user of Cassandra or just getting started, you may be aware that there are some unique constraints with data modeling. Now, there's plenty of resources that are available for you to learn Cassandra data modeling, but once you get past the basics, you're going to run into some real-world challenges. I'm here to help you work through these challenges so that you can meet them head-on. Apache Cassandra and DataStax Enterprise have been proven as the database of choice for cloud applications. Everything from customer-facing retail systems to Internet of Things systems. For this series, we'll focus on the hotel application domain. Let's do a review of the recommended approach for Cassandra data modeling. There are plenty of free resources available to learn Cassandra data modeling. First, there's my book, Cassandra, the Definitive Guide, the second edition. The entire data modeling chapter from this book is actually available for free on the O'Reilly website. DataStax Academy also has an excellent course on data modeling. You should really work through the exercises. Finally, there's the Killer Video application, which is maintained by the Evangelist team. This is a great example of a data model in a real-world application. Let's start with a quick look at how we develop data models for applications using Cassandra. I'm going to use the hotel domain example from my book. We might use this to build an application that allows users to shop for hotel rooms. The process starts with entity relationship data modeling. You can see here the key nouns in our domain: hotels, nearby points of interest, the rooms offered by each hotel, along with the amenities and when the rooms are available. Finally, there's information about guests and their reservations. One of the great things about starting your data modeling this way is that it is agnostic of what type of data store you're going to use, whether it's a tabular style like Cassandra, a key value or document store, or even graph. This becomes important later on when we discuss multi-model. Once we've identified the entities in our domain, the attributes and relationships between them, we need to think about how our application is going to access the data. This is really important for Cassandra data modeling. The strategy is different than typical relational data modeling. Instead of doing various normalization steps, we use a query-first design approach. We design tables around the query our application needs to support. Looking at this representative set of access patterns for a hotel reservation application, you might imagine this goes along with a user interface storyboard. A customer enters a point of interest to get a list of nearby hotels. They pick a hotel and view the various rooms available at the hotel. The customer decides to book a room and a reservation is created. They may come back on a future visit to the site to look up the room by various criteria. There are also access patterns for hotel users who want to see who is coming to the property. Once we have the access patterns defined, we'll do some logical data modeling. This diagram shows a logical data model for a hotel application using a Chebotko diagram, named after one of our colleagues here at DataStax. You'll notice that the access patterns from the previous view are referenced here to show which table supports each of the queries. The diagram focuses on the shopping portion of the application. We'll leave the reservations for later. If you follow the arrows, you can see how the tables relate to each other. Each step in our application workflow is supported by a subsequent query. At this point, we've already started to identify the keys for each table. This will determine how the data in each table is partitioned and organized for queries. The next step is to create a physical data model. At this point, we assign types to each of our attributes and identify the Cassandra key space that will be used for each table. The final step is to write the actual Cassandra query language schema that will define our key space and our tables. At this point, you might be thinking, hey, that's a really nice data model, but it's too simple. My application is way more complex than that, and I have some real challenges. I totally sympathize with you. These simplified models that we create to learn hard topics can only take us so far. One of my readers was kind enough to really engage with the material in the book, and he started asking some hard questions, which I've shown here. I'm not going to read these to you in detail, but if you look closely at the highlights, there are some interesting challenges here. If most of the tables reference a hotel by its ID, where did the ID come from? How do we ensure uniqueness of hotels, point of interest, names? Should all that data be stored in Cassandra? If not, where else would we put it? These tend to be the typical questions that a lot of developers and architects have when they're trying to build real applications with Cassandra. So I thought I would take these reader questions along with some others that I hear frequently and distill them down to a list that we can look at one at a time. There are questions like, how can I ensure the unique identity of my records and still be able to find them later? This is a question of identity. How do I navigate the relationships between different data types stored in my tables? This is a question about relationships. How should my data model relate to my architecture? This is a question about architecture. When should I use Cassandra versus other data models like key value or graph? This is a question about multi-model. How do I support additional queries without having to create a lot of new tables? This is a question about search. How do I ensure my data model will perform well? This is a question about scalability. Okay, well, those are the questions. Let's start finding some answers.